Good day everyone. Integration part 13. Now I will do few special sums here and then I will tell you three concepts. Okay. Why I call them special sums? Directly you won't be able to say that we have to do it by completing the square method. We have to do it by partial fraction. We have to do it by integration by parts like that. So we have to do certain steps, certain formula application or certain simplification, etc. And then only we will be able to identify what method we have to follow. Okay. So now the first sum I will take is I is equal to integral secant cube x dx. Now, sin cube x you know how to integrate, cos cube x you know how to integrate. Using the formula sin 3x cos 3x, we will be arriving at what is sin cube x, what is cos cube x in terms of multiple angles, and then we will integrate. But we can't do secant cube x in that way. One thing that you may think here is you can do it using integration by parts, taking the secant cube x as the u function and dv as dx, isn't it? Okay. But if you try it, after applying the integration by parts, you will get I is equal to I. You will get stuck there. You can't proceed further. So here, let me teach you how to go about this. So, you write now secant cube x as secant x into secant squared x dx, right? Now, secant x as well as secant squared x are trigonometric functions. Usually, when will we apply integration by parts? Only when you get a product of two different functions, isn't it? But here, we are going to apply integration by parts. That is the speciality in this sum. Now here, you know, the secant squared x dx is very easily integrable. That is a straight formula. So now, I am going to take the secant x as the u function. I will write my dv is equal to secant squared x dx, right? Now you know you have to differentiate this, you have to integrate this. So you will get now du will be secant x tan x dx, and if you integrate you will get v is equal to tan x. Very simple. Now let us use the formula for integration by parts. Integral u dv is equal to uv minus integral v du. This u dv will be nothing but I, that is equal to u into v. So you will get secant x tan x minus integral tan x into du is secant x tan x dx. Now let us write the first part as it is. That will be secant x tan x minus, this is tan squared x into secant x dx. You have your tan x, you have your tan x, right? Now I want to write this tan squared x as secant squared x minus 1. So I will get secant x tan x minus secant squared x minus 1 into secant x dx. Let us expand the bracket and see what we get. So now this will be secant x tan x minus secant squared x into secant x will be secant cube x dx. That I will put as one integral. Then minus into minus will be plus integral secant x dx. Okay. What is the second term? That is nothing but your I. So now you will get secant x tan x minus I plus integral secant x dx. Bring this minus I to the left hand side. You already have your I there. So now you will be getting 2I. That will be equal to secant x tan x. Okay. Then plus integral secant x dx. You have a straight formula for integral secant x. So now you will get secant x tan x plus log mod secant x plus tan x plus c. I is equal to, bring the 2 here as 1 by 2. So you will be getting 1 by 2 secant x tan x plus log mod secant x plus tan x plus t. Is this sum clear to you? So here what you have to understand is, even though we have two trigonometric functions, we are using here only integration by parts. Then we get a minus I here, we take it to that side and then we get that. Okay, is it clear? We will move on to the next sum now. Second sum, I is equal to integral sine inverse root x by a plus x dx. Actually, this sum is from NCERT exemplar. Exemplar sums are important. Now, first we have to think what we can substitute for that x so that the root will be removed, and if we get in terms of some sign, then you know sine inverse of sine x is equal to x, like that we can write, isn't it? So now, let me think what I can substitute here. So now, you have a plus x here within the root in the denominator. So how can we remove that root? If you put x is equal to a tan squared t, what will happen? A into 1 plus tan squared t, which will be secant squared t. So we will be able to remove the square root, we will be getting tan t, right? Secant t. So now let us write, put x is equal to a tan squared t. Whenever you substitute, immediately you have to differentiate. So now, if I differentiate, I will get dx is equal to a into 2 tan t into secant squared t dt, right? Now, this is not enough for me. Then I have to bring that t back to x in the final answer, isn't it? So let me work out that also. So now I will write here x by a will be tan squared t. That means tan t will be root x by a and t will be tan inverse root x by a. Is these things clear? What is x? What is dx? What is tan squared t, tan t, and what is t in terms of x? Okay. So now let us write I is equal to integral sine inverse root a tan squared t by a plus a tan squared t for dx 2a tan t secant squared t dt. Okay. Now, the 2a is a constant. Let us take it outside. So, sine inverse. You have a tan squared t here. If you take a common from the denominator, you will get 1 plus tan squared t, which is secant squared t. So, you will get a secant squared t. Then here I have tan t secant squared t dt. So, this a and a will go. If you remove the root, you will get tan t by secant t, right? So, 2a integral sine inverse tan t by secant t. Then you have tan t secant squared t dt. Don't cut this. This is one sine inverse function, remember. So, now let us write 2a integral sine inverse tan t is sin t by cos t. Secant t is 1 by cos t. Reciprocate it, you will be getting cos t by 1. So, this will be that bracket part. Then write this tan t secant squared t dt. Cos t goes. What is now sin inverse of sin t? That is t. So, you get your I is 2a, here you get a t, then you have tan t secant squared t dt. So, when you come to this stage, you know now you have to use integration by parts. T is an algebraic function. Tan t secant squared t is a trigonometric function. So, we can use integration by parts. Okay. So, now the I will be let us write that 2a here. I will just write the sum here again. T tan t secant squared t dt. U is equal to t. So du is equal to dt. Then dv is equal to tan t secant squared t dt. We have to now integrate. You know it is not straight, you have to substitute. So now we can substitute here tan t is equal to z. So secant squared t dt will become, secant squared t dt will become dz, right? Tan t is z, so that secant squared t dt will become dz. So now you will get integral dv is equal to, here you will get z dz. So v will be z squared by 2. What is z? Z is tan t. So tan squared t by 2. Is it okay? So now let us write the formula. Integral u dv is equal to uv minus integral v du. So this is I. Now of course the 2a is there, that I will include here. So now I will write 2a, then I will put a bracket. U into v. U is t and v is tan squared t by 2. So t into tan squared t by 2 minus integral. V is tan squared t by 2 and du is dt. So you will get here tan squared t by 2 into dt, right? So now here, if I remove the bracket, actually these two can get cancelled, isn't it? 2 is outside and you have a 2 here. So we will be actually getting a into t tan squared t minus this tan squared t I will write secant squared t minus 1 dt. You know secant squared t, the integral is tan t. For 1 it is t. So now let us write it is a into, this I have to write as it is. Okay. Then minus, for this it is tan t. You will get a plus here, plus t, then c. Now what remains now? The t we have to substitute in terms of x. So now if you have a t, you should say tan inverse root x by a. If you have tan t, write root x by a. If you have tan squared t, write x by a. Since we have written everything in the beginning, now it will be very easy for you. So now you will write this is a into t is tan inverse root x by a. Tan squared t, that will be x by a, minus tan t will be root x by a, plus t will be tan inverse root x by a, plus c. Okay, we can bring the a inside now. For the first term, a and a will go. So you will be getting here x tan inverse root x by a. Okay. For the second term, you are having root x by root a. This a comes, so you will be getting minus root ax. Because numerator you are having a, denominator you are having root a. Okay. Now, for the third term, you will get a tan inverse root x by a plus c. We can actually combine these two terms because tan inverse root x by a is common, so that the answer will be a bit neat. Tan inverse root x by a into, here you have an x, there you have an a. So x plus a. Write this term as it is, minus root ax plus c. Do you follow this sum? So you do it yourself once, then it will become clear to you, right? Now we shall move on to the third sum. Third sum, I is equal to integral secant x by 1 plus cosecant x dx. Definitely it will strike that you can write secant x as 1 by cos x and cosecant x as 1 by sin x. Yeah, that's correct. Let us proceed. So you will get here 1 by cos x, 1 plus 1 by sin x dx. Let me take LCM here. So you will get 1 by cos x by, you will get sin x plus 1 by sin x dx. Now we shall reciprocate the denominator fraction part. So we will be getting 1 by cos x into, okay, this will become sin x by sin x plus 1 dx. That is, I will write it properly, sin x by cos x into sin x plus 1 dx. Now is one important step we have to do, otherwise you won't be able to proceed further. Now I am going to multiply the numerator and denominator by cos x. I will tell you the reason when I do the next step. You will yourself understand why we do that. Okay, what I am going to do? I am going to multiply numerator and denominator by cos x. So now I will now become, I will get here sin x cos x then dx. Here I will get cos squared x into sin x plus 1. The cos squared x I can write 1 minus sin squared x. So I will write sin x cos x dx by 1 minus sin squared x into sin x plus 1. I think now you will understand why we have multiplied the numerator and denominator by cos x, because I am going to now substitute sin x as t. Then I need the dt part, cos x dx. For that only I have multiplied here and divided to compensate by cos x. So now you substitute sin x is equal to t. So cos x dx, that will become dt. So I will be now, this is t. The next part is dt. Here it will be 1 minus t square and this is t plus 1. You can write t plus 1 or 1 plus t, that doesn't matter. Okay. Now this 1 minus t square you can write 1 plus t into 1 minus t. That 1 plus t and this will become 1 plus t the whole square, then 1 minus t. Now you all know this has come to partial fraction, correct? Now this is repeated factor, remember. So you will write the integrand part, you will write it is a by 1 minus t plus b by 1 plus t plus c by 1 plus t the whole squared. Then you know how to proceed. You can yourself take the LCM, find the values of a, b and c and integrate in terms of t, and finally for t you can write sin x and you can get the answer. I hope you can yourself do it. You may not have any problem in that. You have already done sums like this, right? Okay, so I shall move on to the fourth sum now, because up to this I have told you the method and I have brought you to the known concept. Now you can proceed. Okay. Fourth one, I is equal to integral x squared dx by x sin x plus cos x the whole square. It is a different sum only, definitely. On seeing you won't get any idea, you know. Now, in the bracket I am having x sin x plus cos x. If at all I am going to substitute it, because generally we will substitute what is within the bracket, isn't it? If I am going to substitute it, I want to find out what will be the differentiation for that. So I am going to work it out. So I just find it and keep it so that I am going to use it. That is, I want to find d by dx of x sin x plus cos x, that is what is in the bracket. Okay, here x sin x means you use product rule, so you will get x cos x plus sin x into 1, then for cos x you will get minus sin x. So this and this will get cut, so you will get x cos x is the differentiation of this x sin x plus cos x. If you see the numerator, x squared is there, we can write that as x into x, but we don't have a cos x there. So what I am going to do is multiply numerator and denominator by cos x, because I want to get that cos x there. Okay, so now the I is going to become x squared, I will write x into x. Okay, then I am now going to multiply by cos x, I am going to divide by cos x, then I have x sin x plus cos x the whole square dx, right? Do you follow this step? Now, this I need for my dt term if I substitute this as t. So, this part I will write x secant x, right? X by cos x I am writing it as x secant x. Then I will write this as x cos x by x sin x plus cos x the whole square dx. Now, I don't know whether you have guessed. Now, this part, this is actually a combination of a algebraic function and a trigonometric function. Here also you have an algebra function and you have a trigonometric function. But I am going to use again integration by parts. So these are all some exceptions to the rule we can say. Okay, that is why they are all special sums. Now I am going to take u as x secant x. The rest I will take as dv. So the dv will be x cos x by x sin x plus cos x the whole square dx, right? So now the u dv becomes our I. Now I am going to differentiate it du product rule x into secant x tan x plus secant x into 1. Then I will have a dx here. That will be my du. Coming to the integration here, you know I have to use substitution here. For that only we found out what is the derivative, right? So now you substitute x sin x plus cos x is equal to t. So you will automatically get x cos x dx, that is the numerator, that will become dt, right? So I will get integral dv is equal to integral dt by t square, which is dt, that is t power minus 2. T square in the denominator will be t power minus 2. So I will be getting the v is equal to, I will get my t power minus 1 by minus 1 or minus 1 by t, or it is minus 1 by t is x sin x plus cos x. So this is v for me. Is it clear up to this? So now you have got the du, you have got the v. Let us write the formula. Integral u dv is equal to uv minus integral v du. This is I. Then uv, what is u? U is x secant x. V will be minus 1 by x sin x plus cos x minus integral v du. Here is one minus, so let us change this minus into plus, right? So v is 1 by x sin x plus cos x. What is du? Du is x secant x tan x plus secant x dx. Okay, so we have to actually simplify that part. So this is one part of the answer. I will write minus x secant x by x sin x plus cos x. Okay, let me come to that. That is integral. Okay, x into, that is 1 by cos x. Tan x is sin x by cos x plus secant x is 1 by cos x. Denominator is x sin x plus cos x dx. It looks like a big term, but if you write it carefully, it is easy only. So now I will get minus x secant x by x sin x plus cos x. Okay, plus here I am getting x sin x by cos squared x. Here I am having cos x. I think I can take cos squared x as the LCM for the numerator. So I will write cos squared x here. So x sin x plus, here 1 cos x is there. So I will get a cos x. Okay. Then in the denominator I have x sin x plus cos x. Nothing is there. I will write it as 1 so that you will understand. Now you reciprocate this part. When you reciprocate, actually this and this will get cancelled. So you will get 1 by cos squared x. So you will get actually this you repeat as it is. Okay. So here you will get plus integral secant squared x dx. Is that clear to you? I have cancelled the x sin x plus cos x. So this 1 goes up. So 1 by cos squared x, that is nothing but secant squared x, right? So now you know this is tan x. So I will get minus x secant x by x sin x plus cos x plus tan x plus c. So it is not a very difficult sum, but of course you should know certain steps, otherwise you won't be able to proceed at all. So these 4 sums, you can copy down in your notebook, but definitely you have to do them yourself. Then only it will be clear to you. Okay. So now actually I am stopping the special sums here, and I will just say 3 concepts to you which I want you to note down. I am not going to do any sums. I will just say the concepts to you. Then in the next video I am planning to start identification, because generally students find integration difficult for one main reason. Whenever they do sums from the textbook, they know this exercise means it is completing the square method. This exercise means it is partial fraction. Other one means integration by parts. So they do it. But when we suddenly give a sum in the test or exam, they don't know what to do, how to identify which method to go about. So for that, I am thinking of giving some 10 sums, and I will teach you how to identify each sum. For what method you have to go for. Like that I will put one video. Okay. So now I will tell you 3 concepts for you. With that I will end this video. In the next video we will go for identification. One more thing I want to tell you is, if you feel any other sum it is difficult or you want me to do, you can please write it in the comment section so that I can work it out if a video is necessary. Otherwise I can explain to you. Okay. Now let us go to the 3 concepts now. If the integral is of the form integral linear into root linear dx, that is there are 2 linear functions. One is normal linear, other one is within root. Okay. Or you can have linear by root linear. If you have of this format, the linear, for reference I am putting it as L1, and this linear within the root I call L2. Okay. Then only you will have a clear idea. Now you express L1 is equal to A into L2 plus B. Then you equate the coefficients, find the values of A and B, and then proceed. It will be very easy. The second one is dx by linear into root linear. That is both the linear as well as the root linear are in the denominator. Now you substitute L2, that is whatever linear is within the square root, as t squared. The third one is, if the integral is of the form dx by linear into root quadratic, you write L is equal to, that is the linear is equal to 1 by t, and then you proceed. Actually this third one, you have one sum in your miscellaneous exercise, that is in NCERT. Okay, you practice that. Then let us meet in the next video. Thanks for watching the video. Share it with your friends and classmates. Thank you once again.